Hi, this is Alex Casarez explaining the box problem. So the first part that we're going to look at is explaining the values of each sides in order to figure out the volume of the box. So as you can see, I took 20 minus 2x, which is this side right here, excluding this value, x, and this value, x plus x is 2x. And then we get 12 minus 2x, because again, this is the same. They have the same taken out, the chunk that's taken out. So this is basically our first, this is the volume, or the equation for the volume. That's our function of x. So basically f of x equals the quantity of 20 minus 2x times the quantity of 12 minus 2x times the quantity x. And then we'll move on to B. How does the real-world situation restrict the domain of the function that we found? In other words, for what values of x does function from part A make sense in the context of the problem? Okay, so the real world restricts the value of x being 0, because if x was 0, then this would be equal to 0, this whole function. So therefore, it doesn't work. And then for here, it cannot be 10 or 6, because 20 minus 20 is equal to 0, and 12 minus 2x, or times 6, would be 0. So that cannot be possible. So our domain is from 0 to 6. And then using actually on to C, using technology to graph this function, sketch the function over domain that we established. Okay, so I did a better version of it over here after I redrew the problem. So basically this peak point is 262, and this is from 0 to 6, right there. Sorry, my finger was off. And it actually looks a little bit more like this, if you could see it. There we go. And it's more of a zigzag, but compared to this is the real probable way in order that this function can be shown. So then with that, you find that the range is from 0 to 262, and that's it, because it can't be anything else. Or else it would be non-real, because it goes below the x line. So, and then x cannot equal 262, so that's why we leave it with which is a parenthesis instead of a bracket. Okay, thank you.